Good morning, everybody. I'm Lida Melandra from Enartis, South Africa. A warm welcome to our premier virtual stabilization school. We normally do this event as a live event, but with all the changes with regards to restrictions and COVID-19, we didn't want to miss an opportunity to present to everyone on a few extremely interesting products as well as market trends. And so we chose this platform this year to share all the knowledge with you. Today, there will be 3 presentations. In between these, there will be an interactive poll survey, and we really encourage you all to participate in this. And finally, at the end of the 3 presentations, we will open up the Q&A session where the speakers will be available to answer all your questions on any of the products or practices discussed here today. During the presentation, we ask that you please refrain from using the chat box for any general discussions. But if you do have any connection issues, please pop us a message in the chat box and we'll have someone try assist you. There is a message up for alternative ways to subscribe or to listen to this event. The webinar is being recorded and we will upload it to our website and make it available should you wish to refer back or use any of the information at a later stage. So if we go to our first presentation, this will be done by Greta Lanfranchi, our Enartis sparkling wine specialist. She will discuss and demonstrate one of the most important aspects of sparkling wine, namely Perlage. She will also touch on sparkling wine making method known as Petna afterwards. So over to Greta.
Good morning, everyone, and thanks for having me today. My name is Greta, and I'm the sparkling specialist of Enartis. So for this reason, today I will talk about how to enhance the perlage in sparkling wines. I will start talking about the foaming properties and specifically about the surlimousse, which is a product in our sparkling range to improve the foam stability and the perlage of sparkling wines. Okay, let's start from the beginning. We have to think, what's the first thing that a consumer will be looking at when a sparkling wine is poured into a glass? I will say that definitely is the foam, because it's a visible aspect that we are able to consider as the first impact. So what we are looking for is a wide and compact foam, and we want to have a presence of irregular and repetitive small bubbles released continuously to the surface. We wanted to see a presence of several thin lines of bubble rising from the bottom to the top, and then the creation of a color development at the surface of the glass. This is the first thing, the easiest thing that we can look at when we are facing a sparkling wine. Then, all of these elements are related to mouthfeel. So the creamy, the volume, and the roundness feeling that we have when we drink it. And those foaming properties depend on their chemical composition. So surface active substance can stabilize foam by settling at the bubbles film. So we consider tensioactive substance the molecules named amphiphilic molecules. Amphiphilic molecules are those components with a hydrophobic head and a hydrophilic tail. We have to remember that since the gas, so in this case the CO2, is polar and the liquid is apolar, the characteristic of those molecules allows them to settle with their polar head towards the gas phase and the apolar tail towards the aqueous phase, surrounding the CO2 and make it more stable. And you may be now wondering what are those molecules, but as we know, proteins are the best candidates. But more recently, studies have been reported that molecules with a higher percentage in sugar as mannoproteins and glycoproteins, which are rich in arabinose and galactose, are involved in stabilizing foam by settling at the bubble's edge. Because protein have a very small part of sugar, and these make them less soluble. So that's why mannoproteins and glycoproteins, which are rich in we are talking about 90% of sugar and a very small part of proteins, make them more soluble and more stable in wine. To reach this objective, Enartis has developed a product widely used nowadays in sparkling wines. And I'm talking about Surlimousse. Surlimousse is polysaccharide yeast derivatives rich in mannoproteins, in free mannoproteins. The objective of this product is to enhance the elegance of the organoleptic profile. It's to improve the foam quality, to increase the aromatic expression and the persistence, but first of all, to improve the quality of the perlage and to make the foam more stable. It can be used on the first fermentation, but it's most commonly used on the second fermentation, and both on traditional and Charmat method. I find it very useful on Charmat specifically because Charmat don't go through aging, and this is very helpful to get the same effect of bubble persistence and bubble stability that we can get in traditional method aging years or months on yeast. Here I will show you a few examples where we applied Surlimousse, because we did it in many cases to prove its performance. In this case, we measured base wine, the foam quality, and we considered the foam height and the foam retention. Then we made bentonite addition to remove unstable protein, and then we treat a sample with 10 grams per hectare of Surlimousse. What we wanted to show here is, obviously we know that adding bentonite reduces the protein, the unstable proteins, and reduce the foam impact on sparkling wines. Here we added on cold settling at half of fermentation and at the end of the fermentation. But the interesting thing is that, as you can see, look at the dosage of Surlimousse, how is increasing the foam height and the foam retention. So we wanted to compare it with the samples treated with proteins to show you its effect. So I know that protein stabilization is a truly sensitive issue, especially in sparkling wines. But if you want to use, for example, colloid to stabilize tartrates, but in the meantime avoiding hazing in bottle, we have to remove unstable proteins. And this is for showing you that it's possible without compromising the foam ability. But indeed, even make it better by using Surlimousse. Here, another example where we measure the bubble size with and without Surlimousse treatment. We decided to use this program, which is a scientific program widely used in biological studies, to measure cells and microorganism size, and we decided to try it also for bubble size. We saw that it was working pretty good, so we decided to use it to compare the different treatments to show you and to prove the real effect in bubbles reduction. So in this case, we have a reduction in size compared to the control. So it means that the more tensioactive compounds we have, the more the CO2 is surrounded by it, and the more thinner become the bubbles. So this is also related to the volume, crispy and creamy perception in mouth, and also in the roundness. So that's why it's important to focus on the bubble size and the foaming properties. Before moving to the next and last topic, I want to show you this video because I'm aware that having numbers, data to prove the real effect of a product in this case is the core of the research and studies that we made. But to me, the more practical, the better. and this is like my general guideline for everything. So that's why I wanted to show you this video about sparkling wines where we compared a control, so without any treatment, with same sample treated with 5 grams per hectare of Surlimousse. I would say to get focus on the quality of the bubbles. As you can see in the control, the color at the surface is pretty thin and quickly disappear. But in the same sample treated with Surlimousse, bubbles look thinner, smaller, and for this reason I would say less aggressive. The foam at the top is more persistent and thicker. This is about 15 minutes later. We pour the wine. So effervescence is more intense in the sample treated, as you can see, and we still have several lines of bubbles that are still rising from the bottom, and especially we have a big difference at the surface too. Bubbles are still going. And I can tell you that in mouth we appreciate a big difference too, because Surlimousse felt more elegant and creamy, but I know that you have to take my word for it. Okay, so now I want to move to the last topic, which is the oldest sparkling wine that is now becoming more and more popular. I'm talking about the Petna or ancestral method. About this product. So Petna is an abbreviation of Pétillant Naturel, which originally mean that the whole process is made from a native yeast, so spontaneous fermentation and a minimal intervention by the producer. So for this reason, the general expectation of Petna is a wine that has low alcohol content, is lower in pressure than traditional modern sparkling wines. It's cloudy, and this is due to the lack of filtering, and generally has some fresh fruit character, but also can develop some bread, toast aromas that is due to the presence of yeast, and usually have a good acidity, and this is a point that we need to keep in our mind because we have to preserve the acidity in this wine. And another characteristic is it's a wine that it's not meant to be aged. So it goes, I would say that it goes through a partial fermentation, and before finishing all the sugar is bottled in order to trap the bubbles form to consume all the sugar left and make it sparkling. After that, we could tell that it's pretty easy to produce this wine since it doesn't need a lot of attention, especially if we compare it to the modern sparkling wines we are used to nowadays. But it still has some issues that we should check out if we want to introduce some new, I would say, new hints to this old method. So to produce Petna, the majority winemakers start directly from juice. And before finishing the alcoholic fermentation, must be cooled down to stop fermentation at the concentration of sugar residual desired. One another important step is fining with chitosan, our sub-micro-M, to avoid malolactic fermentation in order, as I said before, to preserve the acidity. And then bentonite, in this case Flux Compact, to stabilize protein. We want to stabilize protein for two reasons mainly. First is if we want to add some colloid to reach tartaric stabilization, we need to have a wine protein stable, especially if we have higher dosage in protein and we don't know how they will react with the colloids that will be added. And then to reduce the deposit of the lees, because if we have higher percentage of proteins, we have also higher deposit. After that, wine goes through filtration. I would say large filtration at 5 micron to not hold yeast that will lead the end of alcoholic fermentation, but to reduce deposit in bottle to avoid an excess of it. Later on, the addition of cold will lead to tartaric stabilization, if necessary, of course. And then we have to warm up the wine. Warm up the wine by adding also a few grams of yeast, in this case Enartis firm top 15, to ensure the end of alcoholic fermentation. And also, if you think it's too clear, also to make it more cloudy. Last step is bottling at the temperature of 18 degrees to lead the end of fermentation. As I said before, the majority of winemakers make Petna directly from juice. Some of them, they're made Petnat, and here I decide to put Petnat in quotes because we are talking of a wine that goes through secondary fermentation and won't be disgorged. So some of them make base wine first, and then they go through the secondary fermentation by leaving the yeast in the bottle. So this make this wine a kind of hybrid between an authentic ancestral method and a traditional one. So in this case, the process includes the preparation of the pied de couve to lead the yeast acclimation, and then the addition of sugar to reach the atmosphere desired. And then another important step that I didn't mention before, but is the same also if we are making Petna from juice, is the addition of copper. So we have to check the copper level that must be around 0.5, 0.4 ppm in order to avoid reduction, because we have to remember that we are in a reductive space due to the presence of yeast. So we need to check the copper to avoid the reduction. So in this case, since we start from a base wine, I also decide to mention here the Surlimousse, because we are not worried about having too much deposit at the end, so we are in condition to use yeast derivatives to get the cloudy effect. I would say around 10 grams per hectare, 15 grams per hectare. After the bottling, we don't have to worry about anything else, because this wine, as I said before, doesn't go through any disgorgement step. So this is basically another way to make Petnat more in a modern way, I would say. So I hope you guys enjoy the presentation, and thank you for having me, and feel free to ask anything you want. Thanks.
Thank you, Greta, for your great presentation. We're now going to open our first poll, and we really encourage everybody to vote on this. The question in the poll that was asked is, oops, one moment. How do you improve your bubble stability in sparkling wines? Do you use yeast derivatives and monoproteins? You only use soluble monoproteins? Do you use some of the protein instability for good firmability, or nothing? And we'll just wait for a little bit to see and give you guys the chance to vote on this. It's great. We see that the votes are coming in. Maybe just a few more seconds. Happy to see everyone is actually giving us feedback. Don't be shy, guys. put in your choices and your views. All right, I'm going to end the voting and share the results. I think you can all see. And so thank you so much. All right. So now we are going to go to our next presentation. Barbara Scotti, our Enartis marketing manager, will be discussing our new Super-Tannin Hideki, which is a real significant step forward for tannin protection in wine.
Thank you very much, Lida, and thank you very much you all for attending this seminar. My presentation is about Ideki. Ideki is a Japanese word that means splendid opportunity. And Ideki is a tannin that offers the opportunity to reduce SO2 by using a product that is natural, allergen-free, and vegan-friendly. This tannin is the result of a long investigation on a quite big number of tannins of different origin and belonging to the three classes, gallic, pelagic, and condensed. Initially, we ran different trials to identify the tannins that were the most effective for antimicrobial activity, antioxidant activity, ability in removing proteins, and ability in removing metals. In a second phase, we try to enhance the effectiveness of some of the selected tannins, modifying their extraction process. Actually, adopting different extraction conditions from the same raw material, we can obtain tannins that have a different reactivity once in the wine. For example, they can have a different molecular weight distribution, or we can reduce the content of compounds that are extracted together with tannins, and that can impact both positively or negatively on tannin activity. Because it's much easier for me, I think, to show you an example than to explain with my English, I wanted to show you this picture. This is a petri dish that was inoculated with lactobacteria. Here you see, if I use the laser, here you see the bacteria colony, and in the middle, this disc is a paper disc containing a condensed tannin extracted with a standard procedure. So you see that bacteria don't have any issue in growing close by the disc, meaning that the tannin doesn't have any antimicrobial effect. But what if we change the extraction procedure, if we get a more refined tannin? You see that close by the disc containing the more refined tannin, we don't have visible growth of bacteria, meaning that the tannin in this case has an antibacterial effect. Finally, what is Ideki? Ideki is a blend of the most antioxidant and antimicrobial tannins currently in the market. It is a blend made of a gallic tannin. This is the gallic tannin with the highest number of deep side that is possible to find in nature. Here in the picture, the deep sides are these lateral branches made of two molecules of gallic tannin, of gallic acids, esterified each other. And according to the literature, the higher the number of deep sides, the better the antimicrobial and antioxidant activity of the gallic tannin. The second ingredient is an ellagic tannin whose antimicrobial activity was enhanced with the purification step during the extraction process. And the third ingredient is a condensed tannin. More precisely, is a epigallocatechin gallate. This is a tannin that the vine accumulates in the grapeseed when there is an infection of molds. The accumulation in the grape seeds is a way for the vine to protect the next generation, to guarantee the survival of the species. So the epigallocatechin is a tannin that naturally has already an antimicrobial activity. We were able to enhance this antimicrobial effect again with the purification step that we introduced during the extraction process. Let's see now the enological activities of Ideki. Ideki interferes on lactic bacteria activity. This is the example of a red wine with zero free SO2 and molecular SO2 and with an initial contamination of 1000 cells per milliliter of malolactic bacteria. This wine was divided into parts. One part was added with 50 ppm of Ideki. Then we monitored the malolactic fermentation, and we saw that in the control wine, represented here with the blue line, we had malolactic fermentation onset in 40 days. In the treated wine, we didn't have malolactic fermentation in the 80 days of the experiment. Hideki also controls acetic bacteria. In this case, same red wine, we inoculated 100 cells per milliliter of acetic bacteria and we monitored the acetic acid content. And we saw that in the control wine, blue line, we have an increase, a significant increase of acetic acid content, while in the wine treated with 50 ppm of Ideki, the acetic acid level remains the same in the 90 days of the experiment. Ideki is also a strong antioxidant tannin. Its ability in preserving wine from oxidation depends on the richness in OH groups that we can observe in the three components of the blend. There are many ways for proving tannin antioxidant activity. One of these consists in evaluating tannin ability in preserving wine-free SO2. This first graphic represents the result of a lab-scale bottling trial. We took a wine and we bottled it without any precaution to avoid oxygen solubilization. Part of this wine was added with 30 ppm of Ideki, and then we monitor the free SO2 content evolution for 4 months. In the portion added with Ideki, that is the red line, represents by the red line, we have a slower decrease of the free SO2 than in the control wine. This is the effect of tannin ability in blocking oxygen and free radicals before they can oxidize the free SO2. The second graph refers to an industrial application of Ideki. This is the case of a Brunello di Montalcino, a red wine with a high reputation in the Italian market, that was bottled with 27 ppm of free SO2. Part of the wine was added with 15 ppm of Ideki, and then 1 month after bottling, we check the level of free SO2 in the control and in the treated wine. We found 16 ppm of free SO2 in the control and 22 ppm in the treated one. The red test represents the level of the correspondent molecular SO2. And of course, what we can say is that the treated wine has, after 1 month from bottling, has a better antimicrobial protection coming from the combination of the direct antimicrobial activity of Ideki plus the antimicrobial activity coming from the molecular SO2. And in the same way, we can say that the treated wine benefits from a better antioxidant protection that come from the free SO2 and that assures potentially a longer shelf life. Finally, this is another example of Hideki antioxidant activity. The 2 glasses of the pitcher contain the same wine. You have the control on the left and the wine treated with 7.5 ppm of Ideki on the right. The winemaker did the addition of tannin to evaluate the sensory effect. After tasting, he left the 2 glasses on the table. He went to do something else in the cellar. And when he came back after 3 hours, he took this picture. And I think that this picture explains very well the antioxidant power of Ideki better than many talks. So this said, which are the possible applications of Ideki? Ideki is a natural antioxidant and antibacterial tannin. So we can use it to reduce SO2 addition or to replace SO2 addition 100% in the case, for example, of the production of SO2-free wines. When can we benefit from the use of Ideki? For sure, we can use it during aging or storing wine in bulk. In this phase, Ideki is a perfect complement to chitosan. I make an example. Let's consider a base wine for sparkling where we don't want malolactic fermentation happen. But at the same time, we need to keep a low free SO2 content. In this situation, we normally suggest to use chitosan to prevent malolactic fermentation onset. But let's suppose that at a certain point we need to transfer the wine to another facility for the second fermentation, and that we need to deliver the wine clear and stable. We know that once chitosan is removed, wine remains unprotected. At this point, we can use Ideki that is completely soluble to prolong the antibacterial protection of the wine. Being soluble, Ideki can be used also at the time of bottling, so while preparing the wine for bottling. At this stage of the vinification, it provides antibacterial protection that can be complementary to potassium sorbate and DMDC that are both more effective in controlling yeast than bacteria. And of course, preventing the damages coming from the dissolved oxygen, Ideki helps to prolong wine shelf life. Recommended dosages are 1-3 grams per hecto in case you are looking for antioxidant protection. We suggest to increase up to 5-10 grams per hecto in case you also want an antibacterial effect. Ideki is a neutral tannin. It doesn't impact wine sensory. It doesn't provide color, so you can use it safely also in white and rosé wine. I want to underline that Ideki is a convenient solution to be used in high pH wine. I want to remind that SO2 effectiveness is highly pH dependent. So in high pH wine, its protective activity is often overestimated. Tannin activity is much less pH dependent than SO2. That's why Ideki can be a more effective tool to be used in high pH wine. Very well. Going to the conclusions, I just want to recap the main concepts of this presentation. Ideki is the strongest antibacterial and antioxidant tannin available in the market. Being a blend of different tannins with different structure, different composition, and different optimum conditions activity, it provides protection under a wide range of wine conditions and from different species of bacteria. For its activities, Ideki is the natural, allergen-free and vegan-friendly alternative to SO2. We can use it during wine aging or during wine preparation for bottling, with the goal of minimizing unwanted bacterial modification and to prevent wine oxidation, thus extending wine shelf life. This is everything from one side. Thank you very much for your attention, and Lida, the word is back to you. Thank you very much again.
Thank you, Barbara, for your presentation. We are now going to launch the next poll. And again, we encourage you all to give your view. There are 2 questions. The first question is, what wines do you not use tannins on? White, red, rosé, or none of your wines? And the second question is, why do you add tannins? Is it for color, stability, antioxidant protection, microbial protection, or sensory improvement? Both of these questions, you can have multiple answers. So if you use it for more than one reason, please feel free to vote on those. And just give everyone a bit of time to cast your votes and give us your opinions. Give you 5 more seconds. All right. I think for the first question, it's quite interesting to see what wines you do not use tannins on. And I would have thought the red wines would, obviously the red ones are, but rosé and white wines are obviously limited with tannin additions. And then with regards to why you are adding your tannins, obviously color stability, antioxidant, and sensory improvements are actual things that you do use a lot for. So we're going to end that voting. And we will be going on to our final presentation. So we have Carien Coetzee of Basic Wine, and there has been a real surgence in bag-in-box wines, especially in the premium wine sector. And today she will address the concepts and principles for filling wines in bag-in-box. So thank you, Carien.
Today, I will be presenting on the concepts and principles for the filling of wine in bag-in-box. A recent article published in February this year in the Business Insider stated some interesting findings. First of all, wine sales in South Africa fell by 20% last year amid restrictions on alcohol sales during the pandemic. And that bag-in-box wine sales were more resilient than bottled wine and outsold the latter for the first time ever. Wine in glass bottle sales dropped by 24% to 121.5 million litres, while bag-in-box sales dropped only 10% to 126.3 million litres. So it would seem that COVID had strengthened the trend towards boxed wine, which has been growing over the past 5 years, while the demand for wine in glass bottles has stagnated. So this was quite good news actually for a boxed wine, and interesting that we also see the various different products coming into the market, especially if we look at the different types of volumes available. Recently, there's been quite a lot of premium wines which has been boxed in 1.5 and 2 liter boxes. Now, even though the bag-in-box products are designed for quick and convenient consumption, shelf life issues are commonly reported, and this is definitely something we're seeing in industry, and again, especially with the lower volume products. So for today's presentation, we will be just looking at some of the basic concepts and principles for the filling of wine in bag-in-box and provide maybe some technical specifications and recommendations to try and maximize a wine's shelf life and to ensure that the intended wine quality reaches the consumer. There are different strategies that you can follow to try and improve the shelf life of bag-in-box wines. We won't be discussing all of them in detail today, but I will be selecting a few points which I think is quite important when it comes to these type of packagings. Basically, some of the strategies, first of all, would be to select certain types of wines. I think certain styles of wines and types of wines will fare better in a bag-in-box. So you want to maybe look at type of wines that may be a bit more resistant to oxidation, type of wine that might fare better with a low carbon dioxide concentration, because we have packaging limitations when it comes to carbon dioxide with bag-in-box. And in general, the type of wine that the consumer would expect in this type of packaging. Secondly, oxygen management. This would definitely be one of the factors we'll be looking at in more detail today. It can be very important to maximize that shelf life. In sulfur dioxide, very efficient antioxidant, antimicrobial agent, and super important when it comes to bag-in-box wines. So this would really help to improve and maximize the shelf life. So we'll be discussing today a few things around sulfur dioxide and when it comes to recommendations of bag-in-box. In the final filtration and filling line sterility. Sterility is especially important when it comes to bag-in-box, as the free sulfur dioxide is likely to decline at a faster rate in a bag-in-box compared to other types of packaging. So you really want to make sure that the product is microbially stable. Then you want to avoid conditions that may influence barrier film effectivity, anything that can damage the packaging or have an influence on the film from the bag. You need to avoid conditions or any effects that will have an effect on the effectivity of that barrier. And then lastly, storage conditions, very important. Again, this is not only for bag-in-box wines, but especially for bag-in-box wines. And things like temperature is crucial when it comes to this type of packaging. Increasing the temperature from just 20 to 30 degrees Celsius. Anecdotal studies have shown that it reduces shelf life by half, from 8 months to 4 months. So it's really important to make sure that you have your wines in the correct conditions, you're storing it under the correct conditions. Unfortunately, this is out of the control of the producer by the time it leaves the warehouse and it goes to the retailer or it gets to the consumer. So, but as long as it is with the producer, you really want to make sure that you apply the correct storage conditions to make sure that you have the best shelf life for the product when it leaves the warehouse. And then lastly, just a general disclaimer, and that is that, you know, the general recommendations in this presentation unfortunately does not take into account the specific conditions relating to each winery, to the packaging supplier, and to the different fillers. And for each of these, you know, every wine is unique, packaging types differ in effectivity and composition, fillers also differ in their quality control, you know, so these are general recommendations, but that doesn't mean that it can apply right through the bench for every type of scenario. So there's a bit of interpretation involved, but yeah, the presentation will just look at some of the general recommendations. Before we move on to the different strategies that we want to discuss today, let's just quickly look at bag and box in general. So firstly, it consists of a rigid box, usually made of type of cardboard, and then on the inside you have the flexible bag which contains a wine. Now, this flexible bag is made of multi-layer oxygen barrier films, of which the composition might differ depending on the different providers. And then you have the gland, which is welded onto the film. So this is the type of gland. So the gland will allow filling of the wine, after which, when the wine is inside the bag, the tap will be inserted. And then the bag is placed inside the box for some support. Now, bag and box has got quite a few advantages. Things like recyclability, things like it's easy to stack, and it's easy to use. So there's quite a lot of advantages with using this type of packaging. But one of the main advantages would be the ability to extend the shelf life, or to have maximize the shelf life of a product after opening. So you'll see here that this is now the full bag and box. And then after you use some of the wine or consume some of the wine, the bag will start to collapse. So basically, it's not a rigid packaging like a glass bottle, where if you take some of the wine out, you leave a large headspace inside the packaging. Here, because the bag can collapse, you are avoiding that headspace. And then when the wine is finished, the bag is completely collapsed. You can then also collapse the cardboard box, and that makes it easy for recyclability of the bag. So just because of this collapsible feature of the bag, you know, that really extends the shelf life of the wine once it is opened. So compared to a closed product, like a closed bottle of wine or a closed bag and box tend to have a much shorter shelf life. But as soon as the product is opened, you know, it is able to preserve the wine a bit better compared to a open bottle of wine or a different type of packaging. So images like this, very, very handy. And I use quite a lot of these type of images throughout the presentation, which I borrowed from a website called Performance Bag and Box. And you might want to head over there and just go and have a look. They have a wealth of information regarding bag and box and managing filling and technical specifications, so that you can ensure to improve the shelf life. The first strategy we'll be looking at is oxygen. And you know, premature oxygen of bag and box wine remains the main problem experienced with this type of packaging. So we have an image here of a bladder which is lying on its side. You see there is the film with the gland and the tap inserted into the gland. The bag is filled with wine, and you can also see the headspace. So there's different sources of oxygen. First of all, you have the dissolved oxygen that's inside the wine. That is the dissolved oxygen, which is there when it is filled. The headspace oxygen, there will always be a little bit of space in the bag, which might or might not contain oxygen. And then lastly, oxygen ingress through the packaging, so either through the film or through the tap, or just through the packaging in general, as a way for the oxygen to get to the wine. So the effect of premature oxidation would be obviously an organoleptic influence. There will be a definite effect of the free and the total sulfur dioxide, and we often see a change in the color of the wine. Oxidation is not specific to bag and box. However, bag and box generally do show more oxygen egress compared to glass bottles and its closures. And again, this will depend on the exact composition of the bag, but these are just general observations. I'm going to start with dissolved oxygen. And like I said, that is the oxygen that is dissolved in the wine by the time of packaging. Now, firstly, the dissolved oxygen concentration will depend on the oxygen concentration in the holding and the buffer tanks. If you don't have low dissolved oxygen concentrations to start with, then you won't have a low dissolved oxygen concentration in the bag. And then also not only just the starting concentration, but also the amount of oxygen that you pick up during the filling operation. So different filling operations might result in more oxygen pickup. But this is also not unique to bag and box, but you want to really make sure for bag and box that you pay extra attention to the dissolved oxygen pickup during filling. So number one, ensure that the dissolved oxygen in the tank is low. Keep the tanks full as far as possible. Use an inert gas as a protective blanket to flush the system. You can also just sparge the wines before you start filling if need be. Minimize the movement of wine. You really want to limit any contact with the air, and make sure that it is in contact with the air with the least amount of time possible, especially when the wine is moving. Any stirring of the wine in contact with air must preferably not occur. You have to check your pumps and valves that they seal well and don't allow oxygen to come in, because you want to really prevent that Venturi effect. And temperature's got quite a big influence. Oxygen will dissolve more readily at lower temperatures. So make sure that you fill at the correct temperature for the different wines. And then lastly, oxygen scavengers. It can also help quite a bit to reduce the initial dissolved oxygen in the bag and box. So we've been working with Enartis now for a few months, looking at different oxygen scavengers and the effect of these oxygen scavengers on the shelf life. So very extensive project, and it's a little bit early to give any results regarding this project, but I would like to mention that so far it does seem that there's a lot of potential in terms of products that will help extend the shelf life of bag and box. Next up, we'll be looking at the headspace oxygen. So that is the bubble that is left inside the bag after the tap is inserted into the gland. And this has got quite significant effects on this type of packaging. So where would this come from? So basically, when you fill the bag is lying on its side like this. The gland is at the top, and the wine will be filled into the bag. But obviously, you can't fill it completely because you will have wine spillage. So you need to stop the filling of the wine and leave a bit of space inside the bag. So firstly, we want to look at the headspace volume of this bubble when you do filling, to make sure that you minimize this as much as possible. You really want to try and make this bubble quite small. You can measure it using a very effective cone meter. It can be quite challenging, especially for bags that are covered with a film, which most bags are. And there's a technique to kind of remove this film so that you can visually see the bubble and measure the bubble size. It can be quite tricky and it needs some practice, but there's definitely a way that you can do that. Important when you measure the bubble is to not apply pressure to the bag. You can imagine if you apply pressure to the bag, you will reduce this bubble volume. So you will basically be manipulating the bubble size. And then not only the bubble size, but also the bubble composition is quite important because it doesn't always just contain air. Depending on the filler, they might try and inert that bubble. So when they inert the headspace, basically they're taking inert gas and they flow the inert gas inside the gland before placing the tap. Now this is a bit of a questionable technique. We're not quite sure how effective this is, but I mean it is better than not doing anything at all. Now, there's been some reports that high carbon dioxide wines might release some of the carbon dioxide into the headspace during filling. So as soon as a wine enters the bag, some of the carbon dioxide is released and it'll automatically fill this headspace. So yeah, the bubble will be relatively rich in carbon dioxide and lower in oxygen due to the partial degasification of the wine during filling. But the problem with that is that, as you know, that wines that are destined for bag and box should usually have quite low carbon dioxide concentration. So I'm not sure how much you can rely on this feature. Other things that are often done is to create a vacuum in the bag before filling. Make sure that you don't have any air inside the bag. And then to really fine tune that filling settings to make sure that you have the smallest possible bubble in the bag without causing spillage. So that would be on the filler side to make sure the instruments and that the filling machine is really fine tuned for best performance. The bubble volume really becomes a problem in bag and box due to the fact that in many cases, this volume would be the same irrespective of the volume of the actual bag or the wine that is in the bag. So what happens is in the lower volume products, the wine volume to bubble volume ratio becomes quite low, meaning the bubble volume, remains the same, and while your wine volume decreases. And that can be really quite problematic, and that's why we struggle so much with the lower volume products. So here's just a representation of the total packaged oxygen and what can happen with the lower volume. So you'll see at the bottom, the x-axis is the BIB volume, 1.5235. And then on the y-axis would be the total packaged oxygen. Now, assuming that the initial dissolved oxygen remains the same for all of them, and the dissolved oxygen pickup remains the same for all of them. If you now were to keep the bubble size the same for the different products, and you have a lower volume, then what happens is this TPO will increase quite dramatically, especially with the lower volume wines. So for these products, it's really important that you have even better oxygen management compared to the higher volume products. And then it's also very important that the retailers that are pushing for the 1.5 liters and the 2-liter bag and boxes, they should accept to a certain extent that the shelf life of these products are likely to be shortened, and they can't expect the same shelf life as with the higher volume products. So the next parameter we'll be looking at is the oxygen ingress. So that is basically when the oxygen is entering the packaging in some pathway, and therefore then oxidizing the wine. Now, the oxygen can enter the packaging either directly through the film, and that'll depend on the film composition. It might enter the packaging through the seams where the films are connected. It can enter through where the film and the gland is welded. It might enter through where the tap and the gland is connected. So basically any weaker points in the packaging might allow more oxygen ingress into the packaging and the wine. So like I said, permeation through the film, ingress to the tap glands or seam. And this will all depend on the product that is used, the type of packaging. And you need to ask your supplier for that specifications and ask them to give you a bit more information. And it's quite troubling. The troubleshooting is tricky here. You really don't know what the oxygen ingress of the packaging is, and it's really difficult to test, which we will discuss a bit later. But first, just when to measure oxygen. So in the beginning, with the main wine tank, before filling, you want to make sure that your dissolved oxygen is low enough, and if need be, you can sparge some of the oxygen out of the tank. Then it'll go through filtration, the buffer tank into the filler, where it will be filled, and you'll have your product in the bag. And it's at this point, after filling, where you want to measure the dissolved oxygen, the headspace oxygen, and then also good to have the bubble volume, and make sure you have enough samples of these so that you have a representation of the entire filling day. So you don't really need to measure the oxygen in between unless you really pick up that from before to after there's a lot of oxygen coming in. Then you want to start doing some troubleshooting and to see where is this happening, and that's when you do your before and after strategy, where let's say you measure before filtration and after filtration, before the filler and after the filler, to try and establish where exactly on this line you are picking up oxygen. So this is a graph showing us the dissolved oxygen levels in different bag and boxes after filling. So this specific filling line, they were actually quite good, and they measured quite a lot of the products as it comes off of the line. You'll see here this was just part of day 1's measurements, and then they stopped the measurements, and then day 2 they continued, and then day 3. And what is quite noticeable here is that if you look at day 2, we definitely see a trend in the dissolved oxygen concentration from the beginning of the day to the end of the day in the filling line, where at the beginning of the day, there's definitely a higher dissolved oxygen content in the bag and box as well. At the end of the day, it's quite low. So this is something you need to be aware of. This is also something that's not necessarily unique to bag and boxes. But it's important to know the oxygen performance of the filling line, and preferably you can maybe perform a preliminary audit. You just have an idea of how the oxygen pickup is in certain trends. For instance, also looking at, to check all the filling heads, check the different filling heads, and make sure that you do checks frequent enough, and that you have representative retention samples. So you want to do your checks frequent enough in the sense that it doesn't help you're only doing checks at the beginning of the day or only doing checks at the end of the day. It might change. And also if you're keeping samples as, to make sure of quality control, and you have retention samples that you want to monitor over time, it's important that you have a good representation of your entire filling and not only select samples from the beginning or the end of the day. And then it's important to have the confidence to know that high oxygen and large bubbles are sufficient reasons to stop the filling. If you're ending up with a very large TPO, there's no point in continuing the filling and then compromising the product. So there definitely is sufficient reason to stop and to investigate where the oxygen is coming from. It's important to understand how oxygen evolves in the wine and how it dissolves and how it is consumed. So this is just a mock-up data or graph regarding dissolved oxygen in wine. And let's say, for instance, here the wine is in the tank, dissolved oxygen of just over 1, and you want to start filling your bag and box, but you want to get your oxygen a bit lower, let's say below 0.5. So what you do at this point, you sparge with nitrogen to remove some of the oxygen. Incidentally, you'll also remove some of the carbon dioxide. Might be beneficial to remove some of the carbon dioxide if you want to do that for the bag and box. And then you end up, when you are happy with your dissolved oxygen concentration after sparging, you can start your filling. Now, it is very typical to pick up quite a bit of oxygen during the filling. Obviously, you want to keep that as low as possible, but I mean, it's going to be very difficult not to pick up anything at all. So you'll have an uptake or dissolution where oxygen is actually dissolved into the wine during the filling, and it ends up in the product at a specific concentration. So this would be after filling. Then what happens is that this oxygen is slowly consumed over time by the wine, and that's when oxidation actually happens. The molecules partake in oxidation reaction, so it's no longer in the dissolved form, and it is consumed by the wine. And it's important to understand this mechanism because, first of all, it's important to see the importance of measuring the oxygen directly after filling, because directly after filling, that is when you're going to have your maximum dissolved oxygen. You need to know how much oxygen was there to start with, because if you were to wait a few days before you, or even in some cases a few hours before you start measuring, you might measure much lower than what it initially was, and you won't have an accurate idea of the amount of oxygen in the packaging. So that's the first thing. Then the second thing is, it's important also to understand that if a wine is oxidized, there's really no point in measuring the oxygen content of the oxidized wines. And sometimes it does happen that clients want to see the oxygen concentration in oxidized wine, and there really isn't any point because the oxygen is already consumed. It's no longer in the dissolved form. It's already consumed. It's already caused the oxidation reactions, and it's no longer measurable. And you end up basically here. So now you have an oxidized product. And if you now measure the oxygen concentration here, you're going to get a very low measurement. And it's not going to make sense why the wine is oxidized. And that's just because the wine has already been consumed. So it's important to understand this principle. So measure immediately after filling. And then another point would be that you won't be able to monitor oxygen ingress with wine inside the packaging. And the reason for this would be the consumption that takes place where the molecules partake in oxidation reactions. So in a wine, if you have oxygen ingress through the packaging, over time, this is going to happen slowly and gradually. And small amounts of oxygen is going to enter the packaging and then into the wine, if it does enter. And basically, as this oxygen dissolves in the wine, it is also consumed at the same time. So you won't be able to see this really if you do oxygen measurements, unless number one, there's a lot of oxygen coming in, then you might be able to see it, but otherwise you won't really see it. It might change the curve of the graph in the sense that the curve might flatten quite a bit because there's oxygen coming in, even though the rate of consumption is higher than the rate of ingress. But you don't have anything to compare it to, so in the end of the day, you still don't know what this curve is supposed to look like. So in the end, it is very difficult to measure the ingress, and the only way to really do that would be with deoxygenated water. And this is just a very handy image, also just showing someone measuring the oxygen in deoxygenated water, where there is nothing that can consume the oxygen molecule. So it gives us a better idea of what that ingress is. But it is important that the person or the company that is providing you the bags and the packaging and the glands and the taps they should be able to provide you these specifications, and they should be able to, and even better if they can show you some of these tests that were conducted to prove that the packaging is sufficient for wine and keeps out oxygen sufficiently. So they should be able to have these specifications. Okay, so the next strategy for shelf life improvement would be to look at sulfur dioxide. I'm not going to go through the principle of sulfur dioxide. I'm sure that you all are aware of the exact functions of sulfur dioxide in wine. But before we're looking at strategies for bag and box, I think it's important also to just understand what can happen to sulfur dioxide when the wine oxidizes. So this is part of my PhD studies, and it's a Sauvignon Blanc wine that was aged over 8 months. So in this yellow block would be the wine, no oxygen was added. The wine was bottled here and then allowed to age over 8 months. And we did sulfur dioxide measurements. And you'll see here, there's this initial drop in sulfur dioxide, which is quite normal. We see this in glass as well, other packaging. But then important that we see the sulfur dioxide can remain stable if it's the correct storage conditions were used, and it doesn't really drop much further. But as soon as you continue adding oxygen, that's when you really start to see a drop in your sulfur dioxide. So here in the orange block, it continuously added oxygen. So this would kind of represent almost a type of oxygen ingress into the packaging, and we see that it keeps on declining. Now, if you look here, this drop is after 2 months. No oxygen was added. We lost about from 45 to 30, so about 15 milligrams per liter. And then if you added 7 milligrams per liter of oxygen, so this would kind of represent your total package and perhaps some ingress. After 2 months, it reduced down to 20. So you halved the free sulfur dioxide concentration within 2 months. So yeah, even though it is normal to see a drop in free sulfur dioxide, this drop tends to be quite higher for the bag and box compared to other packaging. Now, looking at what happens after 5 months, approximately, with even more oxygen, you're already down to 10 milligrams per liter, which does not provide any more antioxidant protection. So in this case, the shelf life of the wine is basically, this wine is not sufficient or of sufficient quality to be able to be sold. So yeah, it's important to see that this trend can happen, especially with ingress where the oxygen keeps on coming into the packaging. So the recommendations would be to increase the free sulfur dioxide to as high as possible, and often, you really want to almost push the limits here and really get super high SO2. It does take a bit of time for the product to get to the consumer usually. So there's time for that SO2 to kind of settle, because you do have this initial drop, and like I said, it usually is a bit higher for bag and box than it is for bottled wine. Add the final sulfur dioxide a few days before filling. Quite important that you have to ensure that this concentration is stabilized. So it's not advised to add the sulfur dioxide directly before filling and then continuing. You want to make sure that, number one, it's mixed properly, but then also that the sulfur dioxide that you added stabilized, and wine is a buffer medium. It isn't something that's very static. Certain reactions can take place. So you want to make sure that you have a stable, high sulfur dioxide before you start filling. And then make sure you take enough measurements. You want to make sure that you know what the final sulfur dioxide was before you started filling, especially when it comes to troubleshooting. So to actually measure the sulfur dioxide right before filling, after you think that everything has been stabilized, or even after a few days of measurements, to make sure that it is stabilized before you start filling. If you rush this process, that is when you end up with a lower sulfur dioxide than what you intended, and you might run into some problems. So you should not assume that the amount of oxygen that you added is actually in the free form. But just another example of the quite dramatic effect of oxygen on sulfur dioxide. So there's two scenarios, and this was a study done in France, where they bottled a Sauvignon Blanc and then stored it at 17 degrees Celsius for 1 month. So only 1 month. And when the wine was bottled with a 1.75 milligrams per bottle of total oxygen, they saw a decline in the sulfur dioxide in 1 month of 12%. And when I bottled it with 6.26 milligrams per bottle of total oxygen, a decrease of 44% of sulfur dioxide. So again, similar to what I found in my studies, was that the sulfur dioxide decreased by almost half, and this was within 1 month. So you can imagine this is quite important again when we look at the different volumes of the packaging and the bubble size that is inside the different packagings, where the smaller bag-in-boxes have quite a large bubble to wine ratio, where you can easily get this type of measurement after filling. So again, let's just look at the type of quality control you would like to do when you do bag-in-box shelf life tests, and when you want to make sure that you maximize your shelf life, make sure that your system is calibrated and sufficient to be able to maximize the shelf life. So like I said, first of all, you will do in the main tank dissolved oxygen, sulfur dioxide, get the color measurements, and then just routine parameters. But I mean, this is something that is quite normal to do, but make sure that you know exactly what the composition of the wine was before you started. Now, the routine parameters, like I said, is something that you need to do anyway, but that is things like alcohol and the VA and the RS. It's not parameters that will change over time necessarily, especially, again, this is assuming that you won't have any microbial activity, then things will obviously change. But usually if the product is sterile, we're only looking at oxidation effects, we usually don't see a lot of changes in terms of routine parameters. We see a lot of changes in the sulfur dioxide, and you can see changes in the color and then also in the sensory. So at the end of filling, we'll measure the dissolved oxygen, the headspace oxygen, and get the volume. And again, make sure you have enough measurements. It doesn't help that you were filling the entire day and you only have 2 measurements to show what the dissolved oxygen was like. It is not representative of what you were doing. So make sure you've got enough the data points to be able to support, support the quality control and to be able to establish whether there were problems during the filling. And then during storage, you want to make sure that you retain enough samples so that you can do your own quality control and shelf life tests. So during aging or shelf life, you want to do sensory evaluation, sulfur dioxide, and color. So like I said, there's no point in doing oxygen here anymore. You want to, the main thing I think here would be these 3 parameters, of which sensory evaluation is quite important. And again, enough samples. You also want to check your repeatability. We do see often that there's quite a lot of headspace volume variation from one box to the next. So you need to check the repeatability and make sure that the wines are repeatable. It doesn't help that you have 1 or 2 boxes that's completely oxidized and the rest is fine. So have enough boxes so that you can see whether the repeatability is okay. Then you can decide how often you want to, when you decide that you would like to do this type of shelf life testing, It really is important to do rigorous and thoughtful protocol building. You don't want to get to the end of the project and then realize that you cannot trust your results for some or other reason, and you don't really know what you're looking at. You can't interpret the results. So you really have to think through each step, and it might be a good idea to consult with an external or an internal scientist to ensure that you really reach the end goal successfully, because it's a long-term project, and you want to make sure that you don't miss anything on the way there. So plan ahead, make sure you've got enough retention samples, decide on the frequency of testing. How often are you going to do that sensory evaluation and sulfur dioxide measurements? And this will very much depend on the product that you packaged. So if the product is something that you want to be able to reach at least 12 months, then you can adjust the protocol to be able to address that question. But if the product is intended to be consumed within 6 months, then you can change it to kind of adjust the protocol to be able to perhaps finish after 6 months. But that will all depend on the type of product and the type of shelf life that you're expecting. You need to plan the number of units per analysis, and the type of analysis to be done, and then the sensory planning and tasting setup. This is also quite important, and there's a bit more of thinking through than you would expect. The sensory planning can be quite important. You have to ask the right questions, and ask the right, to get the right answers to your shelf life quality control questions. Keep in mind that the samples retained for shelf life tests will not be subjected to the same storage and handling conditions as the commercial samples. It does happen that the product leaves the warehouse and goes to the retailer, or it goes to the consumer, and after a month or so you get a complaint from a consumer that the wine is oxidized. And if you ask them, how was the wine stored, they would say, oh no, they opened the box, left it next to the braai, and then consumed it over 2 weeks, and then the wine was oxidized. Consumers don't always realize that things like that would have a major impact on the product shelf life. You can imagine that fluctuating temperatures that wine was subjected to, and the wine was opened. So definitely the wine will not be able to have a longer shelf life. So it is quite difficult because you don't really know what conditions your product will go through. So like I said in the beginning, it might be advised to actually put this on the packaging, a type of recommendation regarding storage conditions. And then, there's only so much you can do to try and make sure that the product gets to the consumer in the right condition. But to increase your success, this is not necessarily to increase your shelf life, but to increase the chances of the success would be to fill in smaller batches, not to fill too much and then have a lot standing in storage. Carry the minimum stock, also carry minimum packaging, because the packaging can also be affected if it is stored for long periods of time. And then fill according to orders and ship the product as quickly as possible to make sure to get to the consumer. You don't want to spend half of the product shelf life standing in the warehouse if it can get to the consumer quickly. So these are just a few other tips that you really want to pay attention to when it comes to bag-in-box. Okay, and that was basically the presentation, just a few acknowledgements. Again, I just want to acknowledge this website, baginbox.com, or bib.com rather, that really has a wealth of information regarding bag-in-box, and this presentation specifically, where they looked at the recommended procedures for wine BIB shelf life studies. There's a bit more information than what I showed today, so you can definitely go have a look. And then these two technical documents were also quite helpful, technical specifications of bag-in-box packaging and a guide of good practices. So I would definitely recommend to go to this website, have a browse, look at the different documents. And then I need to acknowledge the different wineries and fillers that has, over, let's say, the past year, allowed me to look at data, especially regarding oxygen, sulfur dioxide, doing sensory tests over time. It really has helped me to understand also the bag-in-box quite much better. And then to Enartis, who's also supporting quite a lot of these research projects, and for the opportunity to present at the Stabilisation School. That's it for the presentation, and I welcome any questions.
Thank you, Carien, for your very informative and concise and complete overview of bag-in-box. We are now going to open up the poll. And again, we please encourage everybody to participate and give your answers. There are 2 questions. The first one is, do you conduct any in-house studies with any of the packaging forms that you're packaging into? And the second question is, what do you expect the shelf life of a 2-liter white wine packaged BIB to be? And there you have 2 months, 4 months, 6 months, 8 months, 12 months, or do you expect it to have a longer shelf life than 12 months? So you can cast your votes, and we'll just give everyone a few more seconds before we share the results. I think shelf life studies are really important, especially when you're putting wine out into the market. You want to know that what you've put initially into your bottle, your bag, is actually the same quality over time, and your consumer is enjoying it as it should be. So I think we're there. I'm going to close the voting. So if we just have a look at the first question, there's quite a 33% of you guys said yes, you're definitely doing shelf life studies, which is great. I think it's something we should all be doing. And then for question 2, I think overriding, people expect 2-liter white wine BIB to at least last 6 months, a few 4 months and 12 months. So maybe that's a question we can ask Carien of what is the kind of trend at the moment, or what are we actually seeing lately with bag-in-box shelf life? I'm sure she has some information for us. So that ends our poll questions. We're now going to open up the floor for any Q&A. So any questions that you have for our speakers, please don't be shy and put up your questions. So we have the first question. What is the effect of surly mousse on carbonated wines? So Greta, if you don't mind answering that question, please.
Yes, so in this case, for the carbonated wines, the principle is the same. We do have interaction between CO2 and mannoproteins. So even in this case, if the wine is carbonated, we probably add surly mousse on the base wine. So we enrich the base wine in mannoproteins and yeast derivate. And for this reason, when we are going to carbonate the wine, we do have reaction, so interaction between the mannoproteins and the CO2, which provoke an improvement in foam stability and bubble stability, I would say. So yeah, the principle is exactly the same because we are referring to the CO2 and mannoproteins interaction.
Thank you, Greta. So Corinne has asked Barbara to answer the following questions. What are the sensory effects of Hideki? Barbara?
Can you hear me? Hello? Can you hear me? Well, I don't know. Anyway, yes, Karine, thank you very much for your question. Ideki is a very technical tannin, so it's pretty neutral. It doesn't impact wine taste or wine aroma. And also regarding the color, is a very pale tannin. So also in white wines, let's say South African Chenin or Sauvignon Blanc, fresh light wine, up to 5 grams, for sure you don't see any color change.
Thank you, Barbara. And then I had a question for Corinne, just on her presentation. What are we currently experiencing with regards to bag and box shelf life? I mean, there was quite a spread from 2, 4, 6, 8, and 12 months. But can you give us some more input on that, or what is happening, or what are we seeing?
Yes. So it seems like with bag and box that, especially the lower volume ones, we really are seeing a lot of problems in the industry. And when it comes to the lower volume packages, it would seem like around 6 months would be pretty accurate. Obviously, it can extend to longer than 6 months, and it all depends on the actual wine and the way it is prepared and its sensitivity to oxidation. But yeah, I would think for the smaller volumes, 6 months, but then again, the larger volumes, a lot of people don't have any problems at all having the product go to 12 months or even extend the 12-month shelf life.
Thank you, Corinne. And we have one more for you. So this is from Manfred. Given that there's already CO2 in the wine, will it help to have a bag and box inner liner that generates additional CO2 over time?
Manfred, for the question. I do think that would be very interesting technology indeed. For it to generate additional carbon dioxide, the first thing we need to keep in mind is the bag's ability to handle somewhat higher carbon dioxide, because carbon dioxide is usually one of the limiting factors when it comes to the wine. You know, what can the bag handle, and the pressurization when it comes to transporting the bag. So that definitely is something we'll have to look at in terms of how much additional carbon dioxide will be generated and whether the bag will be able to handle it. So that would be the first thing. And the second thing is, if a product has a little bit more carbon dioxide in it, it would be it would perhaps be more protected from dissolved oxygen. But exactly how much carbon dioxide is added and exactly the protective effect of this amount of carbon dioxide, that still needs to be established. So we're not quite sure. But in principle, yes, it will help probably help to extend the shelf life, but it all depends because we do have that limiting factor of the actual bag.
One more question from Barbara. What about PET and containing PET that contains aluminium film?
When it comes to PET and the canned wines, it all depends very much on the type of packaging. So yeah, obviously there's quite a lot of difference and a lot of factors to consider when you look at PET and the aluminium film. These types of packagings that all differ in their oxygen permeability. So that would be the first thing to look at. What is the permeability and any possible sculpting effects of these type of packagings? Well, when it comes to shelf life, at the moment it would seem that things like PET, maybe with a better technology, there might be some improvements. With the aluminium, containing a film, a protective film on the inside, the shelf life can actually be managed quite well, especially if you consider that the canned wine is a very reductive environment. There's no oxygen permeating through that packaging. But you do sit with a smaller volume with a larger headspace, the same as I spoke about in the presentation about the bubble. So there you do sit with that problem again. But in principle, the packaging should be able to extend the shelf life of the product. And also remember, when it comes to the aluminium packaging with the film on the inside or the liner, that there's incompatibilities of sulfur dioxide and the aluminium. So as soon as there's any issues with that liner, then you will have other issues coming to the fore, things like reduction in the wine and, in fact, and corrosion of the aluminium. But that will all depend on the liner. So in principle, I think the answer to this question would very much depend on the provider of the packaging and the exact composition. And that will all determine the shelf life. And I can tell you that in my experience that these type of packagings differ quite drastically just between different companies that make them. And I see very different types of packagings and compositions, let's say in the USA or in Australia and in New Zealand than compared to what we have here. So it really is a question for the person that is, or the company that is providing the packaging.
Thank you. Maybe just for Carien, I did see that Andre made a comment about too much CO2 maybe causing the bag to swell more. That was on Ranford's comment.
Yes, so Andre, so yes, your comment, too much CO2 will allow the bag to swell. Absolutely, and I agree completely with you. If you have too much CO2, the bag will swell. You can have leakage problems, so that it can definitely be a problem. That's why I said it's all about the amount of CO2 that you're actually adding to the wine, with the limiting factor being what the bag can handle. But yes, a very, very valid comment there.
And we have a question for Barbara. How does a tannin have antimicrobial activity?
Yes, thank you very much for this question, because yeah, it seems quite bizarre that initially in the initial screening that we did, we ran a lot of trials and analyses measuring the ability of tannins in removing metals and proteins. These activities that are quite interesting for the wine application are actually related to the antimicrobial effect of a tannin. A tannin is able to interfere on a bacteria or yeast metabolism, because tannins can bind transport proteins, can subtract metals that are cofactors for the enzymatic activity. it is in this way, so interfering on enzymatic activities that yeast is able to limit the growth of a microorganism.
Thank you, Barbara. So again, for Carien, if producing organic wines which have lower levels of SO2, how can I maximize shelf life?
So yes, when you're producing organic wines, you often have much lower sulfur dioxide levels, and you'll need to look at other ways to try and extend that shelf life. Well, firstly, you would either have to accept that you might have a shorter shelf life in general, and like also said in the presentation, might be a good idea to perhaps communicate this and the recommended storage conditions on the packaging. Maybe try and communicate and educate the consumer to make sure that they understand that this wine is not intended to age and should maybe be consumed once it is opened, within a certain period. The other things that you might consider is to really master some of the other parameters. So really pay extra attention to your oxygen regime, the temperatures that you're working at, and to compensate for that lack of sulfur dioxide. You want to reduce any handling, and definitely I would recommend then filling in smaller batches and getting it out to the consumer in smaller batches. Then you might also consider, depending on what you're allowed to do with organic wines or the types of wines, is to look at other products that might help improve the shelf life. There seem to be some promising products in the market, but I'm just not always sure what is allowed with the organic wines, but that's definitely worth it to look into that.
Right, thank you, everybody. I think that might be it for the questions. And a big thank you to our speakers and to all of you that have joined our event today. Thank you so much.